All right, so practice test had 5 problems on it. I'm going to do those 5 problems. It's this little half piece of paper that I handed out. The original problem for the first one was find the equation of the plane with these 2 vectors lying in it, and it contains the point 311. So the idea is this. These 2 vectors, they don't have a location, you know. There's just 2 vectors, but 2 vectors do give a plane, except you don't, the plane, you know, it contains the 2 vectors, which don't have location, so we don't have a specific plane until that point. Now that point means, okay, so all these parallel copies of this plane, wherever they are, there's one of them that goes through the point 311, and it's that plane. That's the plane we want. So there's enough information to get one plane. So here's what we do is, you got these 2 vectors in a plane, pretend they're tail to tail, and then find the normal to them. That'd be the normal to the plane. Oh yeah, that's what we're going to do. So I've got these 2 vectors. You want to have I, JK, 1, 2, 5, 1, 0, negative 1. And the normal is going to be negative 2 minus 0. Negative 1 minus 5 is negative 6. We'll take the opposite sign. That's a 6. And then 0 minus 2. So you could leave it like that, but we'll use the vector 1, negative 3, 1, because it's got the fewest minus signs and it's the lowest numbers we can get. So that gives me the equation x minus 3y plus z equals d. And now that's where that point 311 comes in. 3, negative 3 plus 1 equals 1. So d is 1. And that's the equation of the plane for number 1. Number 2, here's the problem. It's a line perpendicular to a given plane. So they said find a line perpendicular to a plane. So it's a line perpendicular to a plane at the point 111. Well, you can see the point 111 is in this plane. 1 plus 1 plus 1 equals 3. So we're looking for the line perpendicular to the plane at one certain point. Okay, that should be enough. Because it's perpendicular to the plane, I know that this normal, 1, 1, 1 here, has to be the direction vector for the line. So the line is 1, 1, 1, t, plus, and then the point is 1, 1, 1. That's my answer. That's the line. That's the right line. Then find where this line hits another plane. Well, this plane is parallel to this plane. It's 4 units away, see, from 3 to 7. So I have 2 parallel planes, and this line is perpendicular to both. Perpendicular doesn't matter. I have the equation of the line. Well, notice, x is equal to 1 times t plus 1. Y is equal to 1 times t plus 1. Z is equal to 1 times t plus 1. There's your x, y, z. So you just say 1 plus t, or t plus 1 plus t plus 1 plus t plus 1. So you have t plus 1 plus t plus 1 plus t plus 1 equals 7. So that's 3t equals 4. T equals 4/3. And that's no answer, but it almost gives me the answer. Put 4/3 in right there, and you get the answer for the second part. This line hits this plane at the point 7/3, 7/3, 7/3. Because you just put in 4/3 for each of these guys. 7/3 for x, 7/3 for y, 7/3 for z. So that's the second part of the answer. So I'll box it down here. The second answer is just the point 7/3, 7/3, 7/3. All right, next 2 problems. Hang on. All right, this time it's just calculations, so this dot product. So you have 5 times 1 plus 2 times 0 plus 0 times 1 minus 5 times 1. So that's 0. These 2 vectors are perpendicular in 4 dimensions. This next guy is, if you do the cross product out, you should get this guy. 0, 0, 1, because it's I cross J. That gives you K. You do the steps if you don't get it. This guy is the length, square root of 64 plus 225, which is square root of 289, which is 17. Works out to be nice. These guys are all divisible by 8, so you get a vector, but it's a nice vector. 1, 2, 3. All right, now this last one, this is problem 4. Give me the plane through these 3 points. So here we go. The plane through those 3 points, we need 2 vectors. Doesn't matter how we get them, just subtract. So whatever way you want to subtract, first one minus the second, or the second one minus the first, just use all 3 points in your 2 subtractions to get 2 vectors to get that normal. So I'm going to do 2, 4, 6 minus the negative 1, 4, negative 3. That's going to give me the vector 2 minus negative 1 is 3. 4 minus 4 is 0. And 6 minus negative 3 is 9. Next vector is going to be negative 1 minus 3 is negative 4. 4 minus 1 is 3. And then negative 3 minus 9 is negative 12. So the normal is going to be that cross product. And that's going to be 0 minus 27. I'm going to have negative 36 minus negative 36. And then I'm going to take the opposite sign of that, but that's the opposite sign of 0. So this is a big 0 in the middle. And then the last one is going to be 9 minus 0. So I can simplify a little bit. I'll use the normal of negative 3, 0, 1. So that's negative 3x plus z equals big D. I've got 3 points. Any of those 3 points gives me the same thing for D. The D is 0. So I get negative 6 plus 6. I get positive 3 minus 3. I get negative 9 plus 9. My D is 0. That's the equation of the plane. And all 3 points satisfy. That's that one. One more problem to go. Okay, so one of these is hyperbolic paraboloid. One of these is an ellipsoid, and one of them is a paraboloid. Okay, well, this guy's the hyperbolic paraboloid, because if you let y equals 0, you get y equals 3x squared, which is a parabola facing up. If you let x equals 0, you get y equals negative y squared, which is a parabola facing down. So in 2 different directions, but at x equals 0 and y equals 0, I have a concave up and a concave down happening in the same spot. I've got a saddle. I've got something like this happening. I've got a place where I've got concave up and concave down happening at the same time. So it's a saddle point. All right, so that's a hyperbolic paraboloid. This guy, everybody's squared and all added together. So that'd be either a sphere or a football. It's an ellipsoid because there's a 3 and a 4 and a 1. They don't match. The coefficients of the squareds don't match, so it's an ellipsoid. Well, that leaves this guy to be the paraboloid, and it is, because 9 minus z squared minus y squared is the same as 9 minus z squared plus y squared in parentheses. So you can see you've got a maximum of 9 when z and y are 0, and then as z and y get bigger, you get 9 minus this number. So the x number starts at 9 and gets smaller, but the cross sections are going to be circles. So it's a paraboloid, one of those paraboloid shapes, but it's opening along the x-axis. The line running through the middle of it is the x-axis. So that's who these are. That was the practice test, and then Friday is the real test. You'll be getting it by email. So, check you later.